Hi everyone, this is EasyPeps and welcome to another video tutorial. In this one I'll show you how to create this kind of effect with some strands guided by some volume noise field. Although the workflow itself is quite simple, it touches various concepts like Dopps, volumes and Vops, all things that as an Houdini artist at some point you'll want to learn to really get the best out of Houdini, so let's get to it. So as a first thing we need some geometry to generate our points, so let's create a sphere. You can use whatever shape you want, I will use a simple sphere. Dive inside and reset the radius with the control and middle mouse on it, set the primitive type to polygon and increase the frequency to something like 15 to have a higher resolution. Now to generate our points we will not use a regular scatter node, because that will give us point only on the surface of the sphere and we want point inside the volume also. So let's create a point from volume and we can increase the resolution a little bit, so let's set the point separation to 0.08 and increase the jitter scale all the way up to have a more random distribution for our points. Also, let's create a null after the points from volume and let's call it out points. So we have our points laid down. Now that we have our points, we need to create a Dopp network for our simulation. And if you're not familiar with Houdini simulation, you may have noticed that in Houdini you both have Dopp network and Pop network, and you may ask yourself what's the difference between it. The answer is basically there's no difference. If you middle mouse on those nodes, you notice that the real name is Dopp network SOP, which is the same for both of those. So basically they are the same node, but the Dopp network comes as an empty network for simulation, and the Pop network, for convenience, it comes with some basic node already created for particle simulation. So in this case, since we will work with particle, we will use the PopNet and it will save us some time. So delete the DoppNet and plug the null into the first input of the PopNet. Dive inside and here we already have our solver, our pop object and our pop source. So select the pop source and it's already set to use the first contact geometry, which is fine. But if you remember, we have the points coming into the network. We don't have a surface, so we need to change the emission type from scatter into surface to all points. And let's hide the guides. And to check if the simulation is working, let's lay down a gravity force, plug it after the pop solver. And let's hit play. Also turn on the real-time toggle. And yeah, the simulation is working, but we don't want to generate points on every frame. So go back into the pop source and into the bear tab on the impulse activation, which is set to 1, which means it's always on for now. Let's write $FF, which stands for current frame, is equal to 1. So basically we are telling Houdini to activate the impulse activation only on the first frame. So we have our points just generated on the first frame of the simulation. So what we need now is to create our noise field from our volume. So let's go back outside and create a box, which will be the bounding box of our noise field. So let's make it like 15 for sides. And let's plug a volume SOP after it. Now this will create a volume primitive, which is basically a box containing a bunch of voxels, the 3D equivalent of pixel, and every voxel can store data. So we will use this voxel to create our noise field. Now just to show you, let's make the initial value to 1 And you can see the resolution of our volume, which is quite low. So let's increase the uniform sampling and change the uniform sampling to by size. And let's try 0.25, which is good for now, I guess. And also change the rank from scalar to vector, because we want to generate a noise field, so we will need vector data for our voxels. Now, right now our volume has a uniform value of 1, 1, and 1 or every voxel. So let's put it back to 0. And instead we are going to create a noise field with Vops. Also, let's give a name to the volume. Call it vel, because we are going to use it like a velocity field. And if you're not familiar with Vops, they stands for Vex operators and allows you to manipulate attributes like you will do it in Vex but with nodes. They works on different components, like you have point Vops, primitive Vops, and since we are working with volume, we need a volume Vops. So let's take one of it, plug in the volume into it, and let's call it like create velocity, and dive inside it. Now delete this output because we don't need it, and as noise we can use a car noise. It needs a position as input, and for our output let's take a bind export, plug the noise into it, and we called our field vel, so it's vel, and it was a vector field, so 3 float for vector. And let's tweak the noise a little bit. We can lower the frequency, maybe play with the roughness a little bit. And we want this to be animated, so what we can do right now is to convert the vector to a vector 4, so we have a 4 component, replace the position with the 4 vector, and as a 4 component we can use the time. So if you go forward in time, you see that it's animated. And to slow it a little bit, we can use a multiply constant. And let's try 0.1. So it should be a lot slower. Yeah. We can try with this value for now. Now, to have a much clearer visualization of what's happening into the volume, we can use a volume trail SOP, and it needs a volume as the second input and some points as the first input, so we can use a scatter from our volume. Let's set it like 100 and into the first input of the volume trail. Increase the trail length, and basically what you're seeing right now is what's happening into the volume after the noise field we created. So, although this seems like the final result is just for visualization's purpose, just keep in mind you can use the volume trail to do this. So, let's create a null after the volume SOP, call it out vel field, and plug it into the last input of the pop network and dive inside. Now all we need to animate our particle is a node called pop add by volume. So basically it will use velocity volume to move particle. So let's delete our gravity because we don't need it anymore. And the field name is already fine because by default it's called vel, and all we need to change is the velocity source, which is not defined by a SOP, but it's a 4 context geometry, which is where we plug the volume SOP. So let's hit play and let's see what's happening. So you can see that basically the particles are moved by our volume. So all we need to do is tweak the parameter here. I like to increase the scale a little bit. Let's try 3. And I prefer to use update velocity for this kind of animation, but it's totally up to you. So that's it. Also, you can turn on the guide and it will give you a plane to represent the velocity field you created. So let's make it simulate for like 10 seconds. And we have our basic animation. So what we need now is to create our strand. So let's go back outside, and to fetch something from a Dopp network, we use a node called Dopp import. And it needs a Dopp network as reference. So let's take the popnet and just drag into this field, and the pop object as an object mask. So let's go back into the pop network, copy the name of the pop object and paste it right here. And we need to change the import style to fetch geometry from Dopp network. So right now with this node we are basically importing the point from a network simulation. And if you middle click on it, you can see we have a bunch of attributes we don't need. So we can delete those with an attribute delete node. And we can just put an asterisk on every parameter. So we just left with the position. Now we have our points. So to create our strands, we can use a trail SOP. And we can change the trail length from 2 to the duration of our timeline, so 250, and change the result type to connect as polygon and disable close row. So there we have created our strands. They are all white, so we can play with the color a little bit, and maybe we can do it with a point Wrangle. If you are not familiar with those, point Wrangle node or Wrangle node allows you to write backs on different components of our geometry, and we can use it to manipulate attribute like we did in Vops, but writing codes. So we can create a float variable called rand, and we can use a rand function with the ptnum +1, so we can avoid the 0.num as an output, cross parentheses and put a semicolon, and after it create a float attribute, call it call, and use it the rand variable we just created. So what we did here, if you go into the geometry spreadsheet, we basically created on our points a float attribute named call, which go from 0 to 1 on every point in a random way. So now we can use that attribute to create a random color. So lay down a color SOP, set the color type to ramp from attribute, and set the attribute to call. The range is fine, is from 0 to 1, and we can tweak the color here. Maybe set it from a light blue to a darker blue. And you can change the interpolation to something like constant, so you have a much neat separation. And if you go on the trail SOP, you can see the result right here. And that's basically it. All I did in my scene is to create some background, some light setup, and the material. You need to remember, if you want to render with Redshift, on the Redshift OBJ tab, you need to activate the render object as strands. You can choose the strand type. I usually use cylinder, and either you can define the p-scale inside the geometry, or here with the default scale, according to whatever scale you want to use. And of course, since we define the color inside the geometry, in the material for the strands, you need to use this red rs point attribute node with the CD attribute, and we plug into the diffuse color parameter so it reads the color we defined into the geometry. So that's basically it. I hope you find this tutorial useful, and don't forget to like and subscribe the channel if you like it. So see you in the next one.